Hello and welcome back to the 4.4 optimization notes. Let's go ahead and talk about the next type of problem, which is the open rectangular box. Let's go ahead and read this. It says you are planning to make an open rectangular box from an 8-inch by 15-inch piece of cardboard by cutting congruent squares from the corners and folding up the sides. What are the dimensions of the box of largest volume you can make this way, and what is its volume? Okay, so let's go ahead and kind of draw a picture of what we're looking at here. We have a rectangular piece of cardboard, and we're going to make a box out of that. And so what we would do to make a box out of this cardboard is we would cut out squares, congruent squares, out of the corners of each of these corners, okay? And we don't know how big these squares need to be, okay? And we're trying to figure out what square is going to give us the largest volume. So we want to maximize the volume. So we want to know how big do these squares need to be in order to give us the maximum volume. So what I want to do, because we don't know what those square sizes are going to be, I'm going to label each of these X. Okay, each side of this square is going to be an X by X square. Okay, so X by X, X by X. Okay, so now what I want to do is, let's kind of draw something here. I'm going to draw a width here and a width here. And I'm going to draw this distance here. I'm going to call that my length. And then I'm going to draw that same distance over here and call that my length. Okay. So this is what I'm just labeling the picture as. I do know that we have a 15-inch by 8-inch. So I know that this distance here is 15 inches. Okay. I know that this distance from here to here is 8 inches. Okay. That didn't look too good. 8 inches. Okay. And so let's just kind of talk about something here for a second. Okay. Let's just draw a little quick picture of what this is going to look like. And I'm going to do this. I'm going to draw a length like this. I'm going to draw a length going like that. And one like that. And that's going to be what my box looks like. Okay. All right. Draw it out like that. Okay. And so this is what my box is. This is an open top box. Okay. And here's what I know. I know that this is my length X. I know that this is my length or my width W. And I know that this is my length L, okay? So what I want to do is if I want to maximize my volume, okay, I want to function for volume here, then my volume is going to be this. Volume is going to equal the length times the width times my height X, okay? And that's how we'd find the volume of that object, okay? So, but what I want to do is I want to put my length and my width somehow in terms of X, okay? Because we've got some measurements here. I want to figure out what my length is. And what I know is that I know my whole length here is 15 inches. And I subtract off a length of X here and a length of X here. So if I wanted to write an expression from my length, then I would just say the whole length, which is 15 inches, whoops, minus an X minus an X. So that's going to give me 15 minus 2X. Okay, and that's my length. So I'm going to come here, I'm going to say my length is equal to 15 minus 2X. All right, and then the same thing we can say for the width, okay? My width is this whole length, which is 8 inches, minus an X minus an X. Okay, so my width then is going to become 8 minus 2X, okay? So that's what I'm going to write over here. I'm going to write that my width W is equal to 8 minus 2x. Okay, and the height of this would equal x. Okay, we've already kind of established that though. Okay, so but what I want to do is I'm going to substitute these values back into my volume function, and we're going to maximize our volume function. Okay, we're going to maximize our volume. Okay, and what we can say is that these equations here are the secondary equations. Okay, and that my volume equation is my primary one. Okay, so this is what we're going to use to take the derivative of. So let's go ahead and do this. All right, let's use volume equals length times width times our height x. And let's go ahead and let's rewrite that as volume is equal to our length, which is 15 minus 2x. So the quantity 15 minus 2x times 8 minus 2x, okay? And then times our height, which is just x, okay? And instead of doing the product rule 2 different times, let's go ahead and just multiply everything out, okay? So we're going to get volume is equal to, let me FOIL this inside part. So I get 8 times 15, that's going to give me 120, okay? 8 times negative 2x is going to give me negative 16x. If I do 15 times 2x, then that's going to give me minus 30x. And then if I do negative 2x times negative 2x, it's going to give me positive 4x squared. Okay, I'm multiplying this whole thing by an x. Okay, so let's go ahead and let's distribute our x and combine like terms. This is going to give me 120 x minus 46x squared plus 4x cubed. Okay, and this is my volume function. This is what we're going to take the derivative of. Okay, so if I found v prime, okay, because we want to maximize this, so let's find our derivative. So we want to do 120 minus 92x, and then plus, what is that, 12x squared? Okay, and so we can actually factor this. But before I factor that, let's go ahead and write it as v prime is equal to positive 12x squared minus 92x plus 120. Okay, and let's go ahead and set it equal to 0, and we get 12x squared minus 92x plus 120. Okay, and so the one thing that I can do here is I can factor out a 4. So I'm left with 0 is equal to, if I factor out a 4, I get 3x squared minus 23x and then plus 30. Okay, so now I can divide both sides by 4. All right, and I still just get 0 is equal to 3x squared minus 23x plus 30. Okay, and so what I want to do, if I'm going to factor that, let's go ahead and use the box method to do that real quick. Let's draw a box like this, this, and this. Okay, I'm going to put 3x squared here. I'm going to put 30 here. Okay, I'm going to have a 3x and an x. And I'm just going to test some values here. If I do x, say we do minus 6 and say minus 5. Okay, the reason why I did that is because negative 6 and negative 5, if I add those two together, I get positive 30. Okay, if I take negative 6 times 3x, that's going to give me negative 18x. And then if I take x times negative 5, that's going to give me negative 5x. And if I add these two numbers together, then I'm going to get negative 23. Okay, so this has been factored now to 3x minus 5 and then x minus 6, okay? And so if we wanted to solve for x here, we would set x minus 6 equal to 0, or we would set 3x minus 5 equal to 0, and as a result we would get x is equal to 6, or we would get x is equal to, what is that, 5/3? Okay, so the question is which value do we use? Do we cut out 6 inches, or do we cut out 5/3 inches? Okay, this is going to be our answer. Okay, and here's why. Okay, if you think about, whether x could be 6 or if x is 5, so if x equals 6 or x equals, 5/3, you have to think about something here. Okay, the largest value for x, okay, that we can cut out would have to be larger than 4. Okay, here's a length of 4. Okay, if you would have to be, x has to be less than 4 for us to be able to make a square here. Okay, and the way that I get that is I take my smallest length, or my width, which is 8 minus 2x, set that greater than 0. And so you get 8 is greater than 2x, and then you divide by 2, which gives you x is less than 4, or 4 is greater than x. Okay, so this is not in our domain. So not in domain. This does not make it possible. Okay, we'll kind of talk about that later. All right, so we've got these values, and I've got x is equal to 5/3. So what I want to do now is use my second derivative to figure out whether we have a maximum or minimum or not. Okay, and so what I want you guys to do is go ahead and let's find our derivative, which is right here. Okay, 12x squared minus 92x plus 120. Let's go ahead and find v double prime. Okay, if I were to find, say, v double prime, then that would give me, what is that, 24x minus 92. Okay, and let's plug in 5/3. Okay, let's find v double prime of 5/3, and let's see what we get. So we end up getting 24 times 5/3, okay, minus 92. Okay, oops, not 29, 92. Okay, so 24 divides 3 by 8, so we get 8 times 5 minus 92. Okay, and so we get 40 minus 92, which is going to give us negative 52, right? And so what I know about this is that this number here is negative. Okay, so v double prime of 5/3 is less than 0. Okay, which means that my second derivative at this point is concave down. So if this is concave down, my critical point here would have to give me a maximum. Okay, so this is just the test to show that we have a maximum value. Okay, and now we still have to go back and answer the question. And the question is, what are the dimensions of the largest box? Okay, or the box of largest volume, okay, that you can make this way. So what you need to do is, we know that the height of this box is equal to 5/3 inches, okay? What I need you to do to ensure that you have actually watched the video and done this, I'm going to be checking to see if you have the width. Find the width for me, and find the length, okay? But you need to use these values here, so just plug in those values of x, okay? I will be checking that to see if you've done that. So hopefully you've done that. You need to make sure you're actually watching the video. So good luck. I hope that this helps. And if you want to get started on the worksheet on the back, go ahead and do that. Thank you. I had a wonderful time making this video, and I hope you enjoyed watching it. See you soon.